So it turns out Unreal is really good at spreadsheet games, which we don't really talk about enough, so let's talk about it. In this case, a spreadsheet game is any game where the primary gameplay is comparing sets of things using numbers. Exciting, right? But that's the main play of most RPGs, most tactical games, most card games, most sim games, most dating games. The play of these games is not about the moment-to-moment joy of clicking on a menu item or slowly walking up a slope. It's about the things, the numbers in your party and the way you compare them to the rest of the world. In an RPG, for example, there's the hero party with their stats and their gear and their actions, and that's a set. And then you've got the enemies, and they've got their set, and then you mash them together using math. Sure, the player has some agency, but it's really the numbers that matter most there. The levels in these games are usually not terribly fun on their own from a gameplay perspective. Like, if you're playing a shooter game, the levels are important because you're going to be aiming and moving and jumping and the timing matters and all that jazz. So the levels themselves have some play meat in them. But in RPGs and tactical games and so on, the levels are usually just a way to surface what sets the player is going to be able to interact with, how they're going to interact with them, and for how long. Here's the ice mountain. It's beautiful, and there's great sound design, and you just walk. But we're going to throw a lot of ice enemies at you. Hope you're ready for it. That's the point of the level, to throw that particular set of enemies at you for a particular amount of time. This is true of almost everything. Here are all of the weapons in the game. Here's the set that's available for purchase in Corneria. Here's the set that the Knight class can use. Here's the set that the Goblins can use. Each of these sets isn't just a subset of the weapons list. Those sets are deployed in a very specific way, so the player interacts with them in a very specific way. The set that is telling you what the Knights can use, well, that set is attached to an equipment filter, so the Knights have to equip from that list. Corneria, that set is attached to a shop with a very specific purchasing interface. Being comfortable deploying subsets into various places and comparing them to the player, letting the player interact with them in various ways, that's the beating heart of these kinds of games. And it turns out Unreal makes it pretty easy. So let's talk about it. I've mocked up a card. Ooh! If you do not know how to get a visual like this, I recommend that you stop watching and go watch a video on widgets first. You can always come back. This is a very simple widget. I already bound the various things to variables so that we can make whatever card we want whenever we want. So if we were to go into the level blueprint here it is, we can just create a widget. There it is. So here is one of the things that matters most to me. You see this? This drop-down list lets you choose from any widget that you've defined, because every widget you define anywhere is added to a database of all widgets. And it turns out, spawn actor from class, same deal. Spawn component, same deal. Spawn data table, same deal. All of these things are added to a list that's available right here on the blueprint, which means that you can put this stuff together without needing to worry about how to reference and dereference things and pass things around. You can just go get it. Over on Corneria, you can just get the list of weapons and get Corneria's part of it. And then you can just get the widget that allows you to show sales prices. You don't have to try and figure out how to add it to a class variable or anything like that. And that's a huge load off of my mind. And if you're not used to other game engines and you're just coming from Unreal, maybe that sounds like an obvious thing, but yeah, Unity doesn't let you do that. Not easily. Anyway, we are obviously going to spawn a card. Here it is. And we can just spawn in whatever card we want. So here is a big red card. Oh, I forgot to add it. Yeah, it turns out that if you don't add it to the screen, it doesn't get added. There we are. There it is. See? Easy as pie. But we don't really want a card. Get it? What we really want is a giant list of cards, like maybe 500 cards. And we really don't want that to be in the form of individual UI elements. Like we don't want to come down here and clone card widget and have card widget underscore a red terrain, card widget underscore attack 14. We don't want that. We basically just want a spreadsheet with all of the information that we can use, and we can update it whenever we want, right? And then we can just have a card visual that pulls whatever details from that card definition that it needs. Yeah, you use a struct for that. A struct is just a way to bundle up a bunch of numbers and letters and shit. So you get a struct here. Here's the struct that we built for our cards. And you can see that it's got the things that we were talking about: title, description, color, and pick. That's the same things that we're spawning in here. But it's also got a bunch of other stuff. Price, available to enemies, invented in year. This sort of setup is fine. We don't need to limit ourselves to what's being shown. Our card definition can contain every value that the card needs to know about in any context. And I mean, if you've been doing this for very long, this seems pretty obvious, but I do know that some newbies don't have this instinct. So I want to nail this to your heads. Your card definition contains more than what you show at any given moment. It contains what you'll ever show in any moment and what you'll ever use to drive any logic. And we'll see more of that in a little bit. But the point here is we really don't want to be passing in cards like this. That's not a very good way to do it. What we really want to do is pass in a card struct, which is what we were just looking at. And as it turns out, I've got a very similar widget called card widget with struct. And it just takes a struct instead. And so when we hit compile here, we can actually change the defaults to whatever we want. Here, we'll make this one green. And then when we go over here and we hit play, there it is. Now, if we change exactly what fields are attached to that struct, it's not going to matter. Unless we delete one of the ones we're actually using, of course. If we add more values to the list of possible cards, they'll all display fine because they all have those 4 entries. So how do we get an array? How do we get a set? Let's go ahead and create a set of cards. All right, we're done. We got a set of cards now. How exciting. Obviously, it can no longer be passed, but that's fine. Yeah, so that was fun, right? I've been throwing around the term set pretty loosely. In Unreal, set is a very specific term, and you can see here, see it says set. We're not talking about variable type set. We're talking about just a group of things. For example, in D&D, you've got your 6 stats, and they're always the same 6 named stats. But that's a set of stats from our perspective. Similarly, if you have 14 fire swords and 12 ice swords and 32 knives, that's also a set. We don't really care what the variable type is. It's just a way of saying that there are things in a group and they're going to be compared to other things in a group at different times. In this case, we would like to show all of the cards in this set of cards, but we don't really have a way to do that. We could create a widget for every single one of them, but then we'd have to manually move the widget around. Let's go ahead and just create a quick little widget. So we'll just use a horizontal box. Drag it somewhere where it's visible. We don't really care very much. Tag it as a variable. Go over into the graph. Create another variable called cards. Make that obviously a card struct array. Kaboom. And we'll make that something that can be passed on spawn. Here in construct, we'll simply go through that. And when we go through it, every single card gets its own visual. Oh, we want the other one. There we are. That red value is just because we need to refresh the node there. We also probably want to define the owning player. Sorry about that. The owning player, just so that it is all nice and tidy in here. Now, if you don't know what widgets are, this might be a little bit confusing, so go learn what widgets are first if you are currently lost. And then over here in our level blueprint, we're simply going to spawn in a hand of cards and pass it that list of cards. In fact, we'll rename this list of cards to cards. Once that happens, we'll just define a couple of cards. We'll just change a value or two to make sure that we can know that this particular set of cards is the one that we entered in. There we go. Hit play, and ooh, it didn't appear. Why didn't it appear? Well, chances are pretty high that I screwed something very, very basic up. How annoying. Event construct for... I forgot to add it. See, it was something basic. You gotta hook things up before they work. That's kind of one of the points of this video, believe it or not. There we are. There's our cards. Passing around arrays of cards is not actually a very good solution. You want to obviously allow for arrays of cards, but when we think about how we want to move things around, tracking down arrays is kind of difficult. They don't really have any sort of meta values. They don't have any sort of like, oh, this array is for this purpose. They don't have any tags attached to them. They're not stored in a database that's easily accessible. They're hard to work with in terms of, specifying which array to use where. You can do it. In fact, if you're using Unity, you have to do it. But here in Unreal, there are a couple of better options. One option is that you can use the save and load system. Save games and load games allow you to store arbitrary things, and you might as well store an array of structs. Another option is to create a struct that contains an array of structs, just to show you how to do that real fast. We'll call this deck of cards. And that would just be something like name, string, and then cards, and then just pass it card struct array. Right, you could work with this variable, and that has some meta value. You could pass it around, you could compile them, you could save them, you could load them. But what we really want to talk about, and I'm sure you were expecting this, we want to talk about data tables. Data tables. Data tables and their close cousin, data assets, are ways of keeping track of large amounts of these kinds of specifications. These are very important to configuring this kind of game because you're going to have large amounts of these specifications. You're going to have 400 swords, and you don't want to have to track down every instance of short sword and manually change the price every time you think that you want to change the price of the short sword. You just want that all in one place. And data tables are great about that sort of thing. So how do you create a data table? It's a very complicated process. You go over here to MISC, and then you click on data table. It gives you a list of every struct in your project. And obviously we want the card struct. There it is. And we'll call this all cards. Easy enough, right? When we open that up, we get this here. And if we decide we want to add cards, they get added. So here's a bunch of cards, right? So these values can be altered to be whatever we want. So we can make this one a short sword. And we could make this one green. And also, you can change these names here if you decide you want to. No, it's not a valid row name because it has a space in it. My bad. Now, one of the things to keep in mind about this is that this is transparently able to interact with CSVs, which means that you can specify this stuff in an Excel sheet. So in order to just see that in action, you can save this, and then you can come down here to where it is in the content browser and just export it to wherever you want. Open it up in Excel or OpenOffice Calc or whatever it is you're using, and you can change those values, including the row names, to whatever you want. Add new ones, delete them, re-export them, and they'll immediately update right here in Unreal. It's a very transparent, very easy way to handle things. You can also just do it entirely in Unreal if you don't like spreadsheets. But trust me, at some point you're going to want a spreadsheet for this kind of game. And you can just make it work. It's no big deal. So how do these tables work, really? Well, let's go over into our level blueprint here. We have a level blueprint, and we don't know what cards we want, but we do know we don't want to specify them. That's not the best way to do it, is it? So what we actually want to do is to create a card reference. And there are a lot of ways to do that. In this case, I'm just going to show you the easiest way first. And that would be to create a data table row handle. Here it is. And you can just specify where you're pulling from and what you're pulling. Notice that these are names, so you're going to want to keep up with the names if you're using this method. So at this point, we are now specifying the card green. And we can pull that in. We can make that a value that we pass to the hand. And it's something that works fine. If we change that value in the data table, we change the card reference. But passing one row is rarely what you want. And maybe you do want to pass an array so that you could do like, oh, well, this is like a one-off set of goblins, and they'll have, green and whatever. But generally speaking, this is not the approach that you're going to want to use when you're trying to wrangle your data, because it's a little bit cumbersome, right? What's a better approach? Well, you switch it out for a data table category handle. What data table? How about all the cards? What column name do we want to figure it out on? Oh well, how about the price? What price? $120. This will give us all of the cards that have $120 value. There are other ways to do this as well, but the point here is that when we're creating these values, we don't have to try and figure out how to micromanage all of this. We don't have to manually cut the table apart and pass specific values to specific places. Data tables are just available. If you want to use a data table, it's already available to you anywhere in your project, in any scope. All of the data tables are easy to grab. And you can just say, oh yeah, in Corneria, we want all of the weapons that are labeled as Cornerian, or all of the weapons that are worth less than $100, or all of the level 1 weapons. This very easily allows you to add specific subsets to wherever you want them to go. And if you want to create one-off structs that don't exist on this table, that's fine. You can do that too. It's just such a welcoming way to do your design, to just say, okay, well, I've defined all of these enemies. Give me all of the ones that are ice related. Give me all of the ones that are ice related and less than level 10. Or give me these specific ones. Oh, I need to do the Corneria thing? Give me all of the gear that is level 1 and attach it to a specific interface that I just choose from a dropdown, an interface I built to allow shops to buy and sell. I don't have to try and figure out how to pass it a specific set of variables or classes. I can just say, here's the sales widget, and here's the set of references I want to put into the shop. And then you can export it to an Excel sheet, and then import it from an Excel sheet, and change it. This is not something that most game engines are very good at. Unity is terrible at this. Ironically, the game engine that is closest to this is RPG Maker. RPG Maker uses this same approach. And I think it's pretty ironic. I think it's pretty fun that some of the similarities that we see here aren't between Unreal and Unity, but Unreal and a very, very specific niche game engine like RPG Maker. Either way, I hope that this was educational. I'm actually not 100% sure this video will stay up very long because I'm not sure I sold it. I'm not sure I explained it very well. Feel free to talk at me below and tell me if you didn't or did understand it. All right? Have a good one.